Welcome to MAPS Week 1, where we look at SLT1, solve rate and ratio problems using multiple representations, SLT2, determine unit rates with rational numbers, and SLT3, solve scenarios using a unit rate. We're going to take an example of looking at ratios and proportions in real life. On the left is a table that lists the number of rolls of paper towels and case. Is there a proportional relationship between the number of cases and number of paper towels? One way to determine this is to compare the items as a fraction. So we have one case per over 12 rolls equals 3 cases over 36. 1 over 12 does equal 3 over 6. And so since these fractions are equal, we can determine that there is a proportional relationship between number of cases of paper towels and number of rolls of paper towels. Let's look at another example of ratios and proportions. Let's say the store sells coffee for $18.96 for 3 pounds, but you only want 1 pound of coffee. How can you find the cost of 1 pound? Well, first you can set up a ratio, 18.96 over 3 pounds equals X over 1 pound. And there are lots of different ways to solve this. One way is to say, how do you get from 3 to 1? Well, to go from 3 to 1, you could subtract 2, but remember that in proportions, the relationship has to do with multiplication. So to get from 3 to 1, you have to divide by 3. And so we can divide 18.96 by 3. Another way would be to cross multiply. 18.96 times 1 equals 3x, and you set up an equation, and then you solve the equation by dividing 18.96 by 3. Hopefully, with the way that you did it, you got an answer of X equals $6.32 for 1 pound of coffee. Ratios and proportions in a graph. Two items have a proportional relationship when the equation relating the two items is a linear equation, and most importantly, that the linear equation goes through the origin, the point 0, 0. The example of right shows the relationship between number of pounds of coffee and the cost per pound. I've gone ahead and put the point 3, 18.96 on there to show you that that point is on the graph of the equation. Another place where ratios is seen is often in scale drawings. Scale drawings can be found on maps or on architect plans for a house or building. So imagine the scale on a map says 1 inch equals 12 miles. If the distance between city A and city B on the map is 3 inches, how many miles apart are the cities? So again, we set up a proportion. 1 inch to 12 miles equals 3 inches to X miles. And to go from 1 to 3, we know we multiply by 3. And so to go from 12 miles to the number of X miles, we can multiply 3 times 12. I also did it another way, 3 inches times 12 miles per inch, and you get the answer of 36 miles. Thank you for watching this video. Hopefully it helps you better understand the material that was done during MAPS Week 1.